Hello everyone, my name is Liu Changhua. I'm from Beijing University of Technology. It's so glad to have this chance to introduce this research. The title of my paper is a deep learning framework for character gait motion control with physical model. I will introduce my research from 4 parts: the research background, the research objectives, the research method and result analysis, the research conclusions. The research background. Generating real-time data-driven controllers for virtual character remains a challenging task. Even if there is a large amount of ready-made high-quality motion capture data, it still requires a long manual processes before it can be used. As animation complexity increased, a very large animation database is needed to ensure that the virtual character can be moved freely in the scene. This method not only consumes a lot of manpower, but also requires a lot of storage space during operation. There are 3 mainstream methods to going with character movement: the data-driven motion synthesis, the physical base, and deep learning. About data-driven motion synthesis, it has 2 parts: the linear base and the kernel base. The linear base, just like PCA, and it has the global way, the local way, and the kernel base has the RPF and the Gaussian processes. Physical base include the muscle-based operation and rigid link articulated figure. And the deep learning, and about deep learning, it has the RNN and the new GAN. On the background above, the research objective of this research. The research objective is to create a deep learning framework for character gait motion control with the physical model. The character will automatically generate the corresponding gait according to the terrain in the real time, and portray the models to solve the problem of excessive data. And about the research method, first of all, the data acquisition. So we need to solve the problem of these 3 parts. First of all, we need to calculate the character orientation. Like the picture of on the right, these 2 men, both these 2 men just walk toward to the screen, but the root joint of these 2 characters are not normal to the screen. So we use the shoulders and the tight rules to calculate the character orientation, and Gaussian filters to reduce the noise when we capture the character motion data. And then we get the footstep match the ground. The foot contact by dedicating the head and the speed of the foot or heel of the character. And then we definition of the gait semantic. Use the binary to define the several semantic label for the gait. the slow walking, the fast walking, and running. And about gait motion model, we want to reduce the number of train joints, control the number of the joints to minimum number on the node, and define the remaining stroke with joints with IK. Like the picture of these 7 key joints, which is the center, is the root node, the shoulder center, the head, the left hand and right hand, left foot and right foot. These 7 key joints. And the other joint, this blue one, we make this with IK. It can effectively reduce the size of neural network and make it more effective to train the joints with the high necessity. The structure of our neural network is like this. It was a 3-layer neural network, and the input is the strategies of the person who walked before and after, and the joints of this character. And we input this, we calculate with the neural network, and the output is the strategy of the next frame, and the joint of this 7 key joint, the position, the velocity, and the angle of these 7 key joints, and the root positions and angle on the ground of the root node, and the contact label. The number of the cells in the hidden layer we set to 256 and train this neural network 30 epochs and spend about 12 hours. And on the runtime, we training this neural network, and we feed this network into a plugin, and we defined the physical model in the game engine, and we can use the plugin in the game engine, and we can use the plugin runtime. And we know we need the character's joint position and speed of the input, and the strategies to input. And in the game engine, the character's joints, the position we could just read in the engine, and the speed we can easily to calculate. And about the strategy, the previous 24 frame we can record in an array, but the after 24 frames we need to calculate. And the more close to the correct the frame of the correct now, and the more important of the frames we need. And about how to calculate these 24 frames, we used a Catmull-Rom spline interpolation method. We used to define the user's input as V and H, which means the vertical and horizon 2 ways, and the value range of -1 to 1. And we convert user's input to 3-dimensional coordinating. And we use the Catmull spline interruption method to run through the path. We now define the correct current frame is the P1, and the previous frame we can just read on the array record is the P0, and we calculate the frame that displacement the result of the input of the users, which is P2, and the result after 1 second, P3. And we want to know this blue line and this one. This is our strategy of after 24 frames. And we use this method to calculate this part of the strategy. And we can get the whole strategy on the game, on the runtime. So let's move on to the result analyze. We choose three comparisons of this method. The one is the Gaussian process, the other is ERG network, and the neural network, but without the physical method. And we define 2 arrows. And the arrow 1 is distance difference between each joint of the motion generated by this method and the motion fusion method. We usually think that the motion fusion method's motion is the man-hand motion, and it was the correct way that all the people think the motion should be. So we define the arrow 1, and the arrow 2 is which the distance difference between the foot and the ground. Just like the foot maybe just floats on the ground, but that was the problem. And the runtime and the memories. And we can simply see that the memory of the Gaussian process was way too large than the motion fusion method. So obviously that was not a usable method. And we choose full motion. The first one is the straight walking, and is the start walking part, the man idle and to start walking. And we can see that ERG network was not too good. Because the ERG network was one of the RNN, and it don't know which joint should be moved at this moment, the start walking moment. So every joint moved, and the foot was just floated on the ground and moving very weird. So when start walking, the ERG network was not good. And when walking stable, every method was worked in a good way. And also we try to get some curve, like when we curve very slow, we got a slow turn. Every method just generating a normal movement, performance good. But when we try to get a sharp turn, just like this, the Gaussian process has a problem, because the Gaussian process was not a trained, but data-driven. So when they lack the data, they cannot generate the movement. So when they lack the sharp turn data, the man don't know what he gonna do. So that's some problem. And because of the Gaussian process method use a lot of memory, and we try the bumpy ground without the Gaussian process. And compare with the ERD network and narrow network, we can see that our method has a very good error to because we can see that the ERD network has a very serious problem of the floating, and the narrow network was not only the floating but also sink into the ground. And our method was very a good performance to feed the train. So it a very good performance on the different statement, and here is a result of our method to when working to running and stable running, it also performs good. Move to the conclusion. The real-time operation efficiency and model size of this method a great advantage. It is a gait simulation model with high stability and can generate effective real-time actions. But here's some problem. The physical model is unstable. It is also related to the physical model of the game engine itself, but yeah, it has a problem. So sometimes the joint jitter still occurs. And derivation of the physical model, many action styles cannot be restored. And this problem we will solve in the future. Thank you for your listening.